Hey everyone, welcome to Intro Physics, Physics 202. Um, I will be your instructor. My name's Todd Duncan. I'll be your instructor for the lecture portion of the class on Monday, Wednesday, Friday at 8 a.m. I'll get to get up bright and early. Um, so what I'm going to try to do this semester is make just short little intro videos each week to kind of give you an overview of what we're talking about that week, what the kind of emphasis is that week, and also that way for when people unavoidably have to miss class for being sick or a sporting event or something like that. You'll have the slides and everything on Moodle and my lecture notes, but you'll also have at least kind of an overview of what I think are the core concepts to make sure that you get out of the reading and looking over the notes for that week. Okay, so this one's for week one, and so first off, just to kind of give you a big picture overview of what the course is all about, it really boils down to the thing that I like about physics that I hope to convince you, if you're not already convinced, that is valuable about physics as a way of looking at the world, is that it basically takes really complex things about what we observe in the world. It's fundamentally boils down to making observations about the world and trying to kind of distill them down to their essence. And there it turns out there are a few simple rules that underlie pretty much everything we see. And if you understand those rules, you can use them to apply to all sorts of interesting situations, whether you're interested in the human body and healthcare kinds of things. You can understand those principles to learn how to heal injuries or illness. You can use them if you're interested in space travel. You can use them to land people on the moon or Mars. You can use them to build bridges, right? I mean, just about everything. Once you understand the core principles, you can apply it to whatever you're interested in at the time. So that's the core of what we're going to do in the class. And the first semester, Physics 202, is pretty much entirely focused on motion. So we're going to start out day one. I'll give kind of an overview of the syllabus and all that sort of thing, and then make sure everybody can navigate the Moodle page okay, and the assignment structure and things like that. And then we'll have you all go out into the world for a few minutes and make some observations about just the motions that you see. That of course we've all seen all the time, right? As people are walking and swinging their arms or running, butterflies flapping their wings, squirrels jumping from telephone pole to telephone pole or branch to branch. Everything, almost everything we see is motion. And so I want to really ground us. It's easy. Physics kind of has a reputation, I think, for being really abstract and mathematical, which is understandable on the one hand, but it's also easy to lose track of the fact that all of that abstraction and all the mathematical structure that we use is its purpose or its grounding is in actual observations of patterns in the motions that we see in the world. People just like us or similar to us over history have observed motions, codified the rules about how things consistently move. And that's what we know of as the laws of physics, right? Newton's laws are going to be a big point of emphasis. Newton's laws of motion are going to be a big subject for most of the semester. So I want to get us started with a real grounding and away from all the abstraction of just making sure that we observe the world and notice those patterns for ourselves. And so then when we build the abstractions in, it has a place to attach and we know what we're talking about. Okay. So a lot of the first day, I'll kind of go over the course material. And then the first day, there's an assignment that's up on Moodle that's just going to have you go out and observe the world and notice patterns in motion that you see and write briefly about it and post that for me on Moodle. So that'll be most of the first day. And then the second and third days of class will be starting to talk about how we make the translation, because it turns out, sorry, how we make the translation from the real world we observe and the patterns into the abstractions of mathematics that become what you think of as the concepts of velocity and acceleration and equations like distance is velocity times time or Newton's second law of motion and things like that. We're going to kind of make the transition from how we observe things moving in the world to how we make mathematical models, how we turn that into equations then, how we graph it, so that you start getting a sense of the relationship between the abstractions that we'll talk about a lot in class and the motions that those apply to. So you can kind of translate back and forth as one of the skills that I hope you'll learn fairly early on because we'll use it for the rest of the semester. Okay, so that's day 2 and 3. Day three, on Friday of this week, we will uh, have kind of a tutorial in class that'll kind of step you through that translation and learning how to turn some very simple one-dimensional motions into the descriptions that we use mathematically to be able to understand them better. And in case you're wondering, I mean, the reason why it's valuable, I think, to convert into these abstractions is because there is a lot you can do, a lot of insights you can pull out that just really aren't possible if you're just looking directly at the world. You just don't have a handle on the simplifications, I think, that are necessary to see some of the patterns. And so that's, even though sometimes some of you might think it's painful to do the abstract way of looking at it, it has a lot of power and it has a lot of value. And so a big part of the course is going to be helping you see that, I hope. Um, okay, so, and just a few kind of detail things. Um, these are all in the lecture slides, and I'll always post the lecture slides. I guess I say always. I certainly will always try very hard to post the slides before that day of lecture so that I know a lot of people like to have them on their tablet and make notes on them so that you'll have that. And then often I will make notes on the slides during class on my tablet. And then if I do that, I'll also post the slides with my notes on them so they'll be up there. Right. So if you have to miss a class sometime, you'll always, or if you just want to review something, you'll always have this intro video for that week that kind of gives an overview of what's important. And then you'll have all the slides and the lecture notes to look back at. And then you'll also have on the syllabus, it lists what chapters in the textbook are connected to the what we're talking about that week, right? So you can make that back and forth. And I know people have different views of how they like to use the textbook. I would highly recommend that you at least look through the recommended sections before lecture that week, just so that you're kind of familiar with the terminology and you maybe know what questions you might want to ask. And then it's also a really good resource. Most of what's really essential, I think, I'll at least touch on in lecture so that I'll at least point you to what you need to go and read. But I know a lot of people like there's a kind of a coherence of looking at everything all laid out in the textbook format that sometimes is helpful. So just to keep in mind, you've got both of those resources, the lecture and the textbook. And then also the labs, we try pretty hard to make sure that the labs are pretty closely correlated and in sync with what's happening in lecture. We can't always do that perfectly just because of the scheduling and people have labs at different times. But just to emphasize that the labs are really important and they're the space where you really get to take the material we're talking about in lecture and see how it plays out in the actual world where you can move things around. And we have some, I think, useful software that one of the first couple, well, certainly the first lab will be focused on translating between, there's some motion sensors that will, as you move around in the room, they graph your motion. And so you can really directly start to see, if I am speeding up, what does that look like on a graph? Or if I'm standing still, what does that look like on a graph? And so on, so that you can make that translation like I was talking about earlier. Okay. Um, a few things just to maybe highlight the overall structure of the class. Um, I look at it as we're trying to explore the universe around us through the lens of physics. And so I try to make it, I hope you'll agree that it's pretty organized, that there's a very definite structure of how we step through things. Everything builds on everything else, so it's really important that you not get behind. So if you're stuck or lost on something, be sure you ask me questions as quickly as possible so you don't get behind on something. So it's pretty organized and structured. But I also think, I hope I like to make it fairly low stress. I really think of the idea, I'm looking at my notes here, as that we're just trying to expand our awareness of the world and discover some things about the world that are really useful and I hope fun to kind of see. I'll try to bring in my background's in astronomy. My emphasis is in astronomy, so I'll try to bring in some astronomy related things. We'll do some telescope nights. That'll be optional if anybody wants to go look at the moon and planets and galaxies and things like that through a telescope and kind of see how the laws we're learning about apply all over the universe. Um, the basic structure of assignments is pretty much like this. So there'll be a homework assignment on Moodle that's due every week. I've tried to set that, just make it consistent that those are always due 5 p.m. on Tuesdays. And the core, they're pretty minimal homework assignment, I think, in the sense that I tried to just make problems that are the essential, like it's almost your test of if you can do those problems, then you understand what we're doing that week. Um, it's really important that you do those problems, that you're welcome to talk to each other, talk to me about the questions and get help answering them. It's really important that you do them yourself and that you actually do the practice and write the answers out on paper and or a tablet and really learn how to work through it. Don't just type in the answer if you think you can guess the answer. They're meant more. I mean, I give you credit for them, of course, because I want to encourage that you do them, but it's more kind of a self-test of your understanding than it is about, that it's not meant to be like a quiz where there's um, the answers are secret and somehow you have to make sure you do it all by yourself. You're certainly welcome to get help and to talk to each other about it, but just make sure that you are actually going through all the steps yourself and that you really understand the steps. And if it's not enough to convince you of that because of your own learning and the importance of knowing these principles, I will have occasional assignments, quizzes during class that'll often be based on the homework problem. So it's in your best interest from a grade standpoint too to make sure that you understand how to do the problems because a lot of that, if you do the homework problems well, you'll have an easy time when we do the quizzes. Okay. And then I already mentioned the labs, and those are really important to really kind of fill in the details of what we talk about in class. Um, and then the other thing that so we'll do various in-class activities and assignments, and often it'll be very interactive. I hope. I mean, it's a big class. There's about 68, I think, students in the class, which makes it a little hard to have as much interactive as I would in a smaller class. But I think we can still do a lot of the kinds of things where I'll ask you a question, I'll have you work on it for a while, talk to people around you, and we'll, kind of work together on because physics is very much about problem solving, right? About learning how to apply the principles to solve real problems. Which brings me to the biggest assignments of the semester are you'll have two exams. They're both take-home exams. Um, One is due in late October, I think the 23rd of October, and one's your final. So it's due on the final exam day, which is December 10th. And the everything else in the class is going to build to those take-home exams, which I hope you'll. It may be a little intimidating the first time, but I hope you'll really enjoy them because the whole idea of it is um, to me, the value of learning physics is to be able to apply it to what you're interested in. And so the structure of these exams is they're basically that you take what we've learned at that point in the semester and kind of make up your own application of it. And I'll help guide you through that in the process. And we'll talk a lot more about that as that gets closer. But I just want to throw it out there to have you be thinking, from day one in the class, be thinking about when we talk about a principle of physics that we learn, where do I see that in my world as I experience it, in your meaning your world as you experience it? Where do you see that? What's something you could apply it to that would be interesting to you? I mean, well, we'll talk more about it later. We've had lots of different examples. Okay, so it'll make sure that the physics that you learn is useful to you because you get to choose what's useful to you and how to apply it. And we'll talk through that process. Okay. Um, the last thing I wanted to just mention is one of the things that's listed on the syllabus um, is is journaling. And one of the things that I think is really important, aside from all of the physics, is just I think one of the valuable things about doing physics problems and learning physics, one of the skills that's valuable that it helps you learn is just concentration, just being able to focus your attention on a question or a problem for an extended period of time. It's very useful in solving physics problems. We're going to talk about, if there's a kind of like a word problem, a story problem that's set up with a scenario, and you're trying to figure out how to think through it. We're going to talk about strategies for how to do that. But just more generally, I think the skill of developing your ability to focus on a question, focus on a problem is useful everywhere in life, right? And so I want to try to spend some time and energy in the class on developing that skill for all of us. And so one of the ways we're going to do that is journaling. So, I just encourage you to have something, I like having a nice little notebook that I can carry around where I can write thoughts down. It doesn't have to be a hardcover notebook like this. It can just be a spiral notebook, or if you'd rather do it, if you use a tablet for taking notes, an iPad or whatever, you can do it that way too. But just have something that you can write notes in about the course. That's not. I'm not ever going to collect these, other than I might ask you to for an assignment. I might ask you to pick something from there and submit it. But I'm not going to collect the actual journals. So they're just for you. Um, but just to have a sort of a reflective space where you can say, "Oh, I'm not understanding what we're doing this week," and sort of write out your confusion so that you know how to ask questions about it. And then when it clicks and you get it, then you can write that in there so that you have kind of a narrative for yourself about your learning process. I think that's really useful. And we'll also, just in terms of practicing the focus and the concentration, I won't always do this depending on the timing, but uh, to start off class every day, I will usually have some little prompt or a picture or something, and I'll just invite us to take 5 minutes at the start of class just to do a kind of a free write, just to get, it's 8 in the morning, we're all still waking up, and just to sort of get our thoughts out there. Where are we at that moment? Sometimes I'll ask you to start thinking about what your preconceptions are about a topic that we're covering that day. Like, what do you know about energy as a concept? And, can you write down different forms of energy or something like that, right? Just to get our minds kind of engaged with what we're working on at that moment. Okay. Let's see. I guess the other just sort of logistical kind of thing is I'm going to try, because the class is big and I would really like to learn names as quickly as possible. One of the things I'm going to do, both for attendance and just for me to help keep track of names, is I will hand out on the first day just some colored note cards. And on one side, you'll write your official name as it's listed in Boxer Online, and then on the unlined side, I'll have you write what your preferred name is and any sort of things you'd like me to know about you and your experience with physics. And then the way I'll do attendance is those cards will be they'll color coded just to make them in separate piles, so it's easier for you to find them quickly. At the start of class, as you come in, you'll pick up your card. While we're all journaling in the first few minutes, I'll come around and you'll have your card, and I'll come around and collect them. And then that way, I have each day both the ability to sort of help myself learn names, and then also that's how I'll do attendance, is just to check who's there. Um, and I'll talk more more about this, but obviously coming to class is really important. So I will keep track of attendance. I don't have a set policy about, if you miss a certain number of classes, it starts hurting your grade in a certain way. I'm just going to keep track of it. And if it looks like there's a problem, then I'll talk to you individually about that, and we'll see what adjustments to make. And I'm not, yeah, I mean, obviously we get sick and we have events and things to go to and things like that. So I'm not expecting that everyone's going to be there every single class period. And you don't necessarily have to tell me if you're gone, if you just need a catch-up day or whatever, right? That's why I've got the system in place, for you to be able to watch this video and see what we covered and look at the notes online and so on. Just, it's for the benefit of your own learning, try to be consistent about mostly being in class, because that's where all the real learning is going to happen, right? Is our discussions and our conversations and so on. Okay, let me know if you have questions about any of that. I think that is all I have to say by way of introduction. And let me just, I'm really excited I really love teaching this class, so I'm really excited to meet you all. And I know a few of you I've met in other contexts before. So I'm looking forward to working with you all this semester. and have a good last, depending on when you see this, I'm creating it a week before classes start. So depending on when you see this, have a good last week of summer, and I will see you soon in class. All right, take care, everybody.